We're talking about Phoenix 1.3. Just kidding, it's Phoenix 1.4. I've been talking about Phoenix 1.3 for the last year, and it definitely was drawn out on our release cycle. So Phoenix 1.4 is not going to be this big drawn out process. It's shaping up pretty well. It's pretty close actually as far as any user-facing changes, big features. We're actually blocked on Jose right now. He's volunteered to rework, refactor some of the channel layer that Sasa Yurik started conversations 2 years ago on how to make that better. And finally, someone is stepping up to do it. That's not me. But internally, we want to make channels much more extensible, the channel transport layer. And user-facing changes, you don't have to worry about. There's not going to be any big code changes for you to have to change in your application. But the big feature coming in Phoenix 1.4 is HTTP 2, thanks to work happening in, yep. Great. It's good people are excited about it. It's not happening by default yet. We can thank the Cowboy team for this. We rely on Cowboy for that amazing web layer underneath Phoenix, and they were put some great work into getting HTTP 2 into the Erlang ecosystem. And right now, you have to change one line of code. So you have to go into your mix file and bump Cowboy 1.2 to 2.0, and that's it. That's the plan right now, because we are seeing some unusual bug reports still being fleshed out in Cowboy 2. So if you do want to use it with 1.4, you just change your mix file, and we're doing some gymnastics internally. Well, we'll check which version of Cowboy you're running, and we'll load the right adapter. But long-term, Cowboy 2 will be the default, but the plan is for the release now to still default to Cowboy 1, and it's going to be an opt-in approach. But for me personally, I was excited about HTTP 2 because we made this channel layer that abstracts the transport. So I thought originally when I was reading up on H2 that we would have WebSockets would be completely replaced, and I could say, look, we had this extensible abstracted transport, and we were able to write a H2 transport. But it turns out the browsers today speak HTTP 2, but there's no JavaScript API to create this bidirectional communication with the server over H2. So WebSockets are still, the gold standard if you're writing browser-based real-time applications. And you can create, Gary Rennie, who did the Phoenix Cowboy 2 integration of the core team, he did write a Phoenix channel transport for H2, but you'd have to use like an Elixir server to use that. You can't use a browser client yet. So really the only interesting feature for me, other than everyone's greater applause, is H2 push is kind of the only useful thing that would affect me day to day. And this is a feature that will really optimize browsers fetching assets. So today, on Phoenix Master and in Phoenix 1.4, you'll be able to push assets as the browser is loading a page. Over that same connection, you can tell it, hey, since we have this connection here, please fetch app.js and please fetch this logo. And this it's going to be much more optimized than we have today, where every new asset requires a new HTTP fetch. So for me, this is the most exciting feature of H2. And the nice thing with plug is this will be backwards. Like if you're running Cowboy 1, you could still do plug push and it won't blow up. So it will let you kind of gradually update to H2. There's a push bang as well that will raise, but by default, if the adapter doesn't support it, it will just passively continue, and the browser will have to fetch as normal. But what will happen with H2 push is you still render your assets as normal. So you'll still write an image tag with the source, a script tag with the source, but what will happen is as the browser's evaluating that HTML, they'll get down to this image source, and it will see like, oh, I don't need to fetch this because the server already told me to fetch it over the connection. And one of the crazier ideas that it might make some purist eye twitch here is Gary Rennie and I were talking, like H2 push is nice, but the issue is I have this implicit coupling between the plug layer, like my controller, and the content I'm rendering in the template. Because I have to know ahead of time, before I render the template, what things I should be pushing. So it's easy to say, like, well, we're going to push our app.js almost always, right? But what about like a user profile picture? Like depending on the content I'm rendering and based on different logic on what data I'm rendering, I may have some conditional logic in the template that is rendering different assets. And then I have to either duplicate that or know ahead of time back on my controller what I need to push. So we said, wouldn't it be nice if we could just push from the templates? So that's what we did. So this is violating the pure function call that we used to have. So static path is the function today that will render the path of the asset, and we're introducing a static push function. So if you notice the slight change, static path, static push. And this will push the asset from the templates. So like if you hate this idea, just don't use it. But so this is a side effect, right? Like when you call a view render, it's actually going to do a side effect and send a response from a template render. No big deal. So yeah, this is a trade-off, but I think the convenience by and large outweighs this purist problem, because I think Phoenix templates are great. Because if I'm writing a channel application, instead of creating like a single-page app and a ton of JavaScript, I will just do like a Phoenix view render to string and just push updated HTML blobs to the browser. So I still think a pure render call is what we want, but that's only on a case-by-case basis. So if I want a pure render, I'm going to have to necessarily remove the connection from all my static path calls and pass my endpoint instead. So if I already have to touch my template code, I think the static push, it would be fine to have to change that back to a static path if I want to go back to this pure render approach. And like I said, it's opt-in, it's an explicit function call. So it is a side effect, but I think by and large, we want people to continue falling into the right thing. And for me, the right thing is being as optimized and fast as we can be. So if by default, Phoenix in your app layout does a static push of your app.js, the moment that you have H2 support, it's just going to be optimized for your end users. You don't have to then remember, oh, I should add this extra push to a controller somewhere or to a plug. It's just going to happen for you. So for me, this is going to be a big win for users. But if this makes your eye twitch, then don't use it. And we have some other innovative, exciting features. We're going with explicit router functions for Phoenix 1.4. So today, we had a problem where our router module, you have like my app router helpers. It's a dynamically generated module, and then we import those functions in your app web.ex file into your router, into your controllers, into your views. So you have functions that seemingly appear out of nowhere, like job path here. Like it reads nicely, I can say redirect to job path, but where is job path defined? If I try to do like a project search as a newcomer for def job path, I'm not going to find it. So then I go into xdoc and I try to find where job path is defined. I'm not going to find it in xdoc either. So we want to go with a more explicit approach here and just say routes job path. So I know immediately where this is coming from. So it turns out there's some compile time benefits of this as well, but for us, this just makes it much clearer what's happening, and we avoid kind of importing all kinds of things and not knowing where they're defined, especially from a dynamically generated module. So the plan for Phoenix 1.4 is to have an explicit alias in your app web file, so that routes that seemingly came out of nowhere will just be an alias app web router helpers as routes. So we're dropping this helpers namespace because this is something that we borrowed from Rails, and it turns out like helpers in Rails were like a Ruby mix-in, kind of like a bag of methods that were mixed into classes. And if you come into Elixir, it's like taking that approach. Like every module in Elixir is a helper. So the word helper isn't helpful at all in Elixir. So we're dropping it, because I want to, because then everything becomes a helper. So for us, it's just the routes of the router. So in 1.4, we can't change that dynamically generated module because it would break. So we're just doing an explicit alias. So today, everyone's upgrade path is, if you don't want to type routes in your app and you're unhappy with this change, great, just leave your app and import the functions. Otherwise, you can just add this alias in your app web file. And then Phoenix 2.0 will just change it to app web router routes. And if people don't get too excited about this 2.0 flag, like this is just like when we are happy making breaking changes, we'll release 2.0. But it's just there's no roadmap for a 2.0 release. That's just when we want to make the bigger breaking change, we'll make it, and that's what the module namespace would be. And then we have focused on development compilation time. This is an exaggeration here, but we like to promote productivity in development. Like we call it refresh-driven development. Like you make a change to a file, and then Phoenix Live Reload fires, and your browser has reloaded before you even can notice half the time, usually. And but what we were finding is people were making seemingly small changes. They'd open a file and they'd make a small change to it. They'd refresh their browser, or Phoenix Live Reload would kick in, and then Mix would be like, hey, I'm going to compile the whole project for you. And this was confusing to people because they're like, I touched one plug in my app and it had to compile like 50 files. Like, what's going on? So I'm going to kind of walk you through why that was happening and what we did to fix it. So the takeaway shouldn't be that like Elixir's compiler has a problem. It was just the way we were doing compile time optimizations was creating compile time references. So we'll go on a little bit of a metaprogramming deep dive. So what was happening, your router pipeline would say something like, hey, I'm going to authenticate, call an authenticate plug. And it's going to take some options, right? And then we'd write that plug. Every plug has to have an init and a call function. And the key thing to kind of internalize is the init function on a plug is called at compile time. So in our case, we have like, let's say our plug allows the session key to be configured. And then we are going to default those options and convert it to a map for pattern matching downstream. So at runtime, every time call is run for every new request, we have that pre-munged list of options. So this way, like if we have 10,000 requests a second, we don't have to say, okay, take the keyword list with session key, default, convert it to a map, and then run your code. There's no reason for us to do that 10,000 times a second if we can do it once at compile time, right? So this is an optimization that we want. This is a good thing, but we need to understand, I guess, why our compile time issues happen because of this optimization. Because I'm going to put that plug into a pipeline somewhere, and what plug is going to do is, like, our browser pipeline is going to have like plug fetch flash, plug protect from forgery for cross-site request forgery protection, and then at compile time, plug is going to generate a nested list of case statements or expressions. So when you call a bunch of plugs, like ultimately, all that happens is it just does case plug.call, the options that were computed, and if it was halted, it just returns a connection because the plug pipeline was halted. Otherwise, it continues, does another case into the next plug, and literally it's just a bunch of seemingly infinite nested case statements that we would not want to write by hand. But we can see here the code that would be generated is this case expression in the session key UID map. Like that was baked into the generated code at compile time, right? So at compile time, we call auth user init, we get that value out, and then we generate code that literally just places that map in the program. And this is a great optimization, but this is where our compile time references start to build up, because at compile time, since we have to call auth user init, that authentication plug likely is going to call like your accounts context, right? And your accounts context is going to do something with your accounts user schema, and that could potentially cause a cascading compiler references to a large part of your application by seemingly changing just one line of code in this plug. So that was unfortunate, but we want this optimization, right? So what we introduced is in plug, we now have a plug init mode option. So the plug builder has a compile function that will just produce an AST of that case expression. And now in plug, I think 1.5.2, I don't know if it's released or it's still RC, but 1.5 is released. So now plug has an init mode that defaults to compile time, but if you tell it to, hey, please generate a runtime init mode, it will just bake in the call to the plug init into your case expression. So if you get 10,000 requests per second, your auth user init would be called 10,000 times. But in development, this is not a problem for us, right? We get the same semantics of the code, but we're calling auth user at runtime instead of compile time. So we're never going to experience a slowdown from this in development, not under load. So we get the compile time benefits by avoiding those compiler references, but in our test and production environments, it's going to be the optimized code. So that's the big change to our development or our compilation process. So if you did have issues with large compilations and development, please talk to me, because I'd love to have people try this on master to see kind of the comparisons of compile times. But this should be a big help if you did have large issues with long compile times in development. And another big change is we're moving to Webpack for our asset manager when you run Mix Phoenix new. Yeah. A lot of people, I think a lot of people would be happy to hear that. And I won't spend too much time on this. 3 years ago now, 2 years ago, We were evaluating all of these asset builders, and it was a close call. We narrowed it down to Brunch and Webpack, and at the time, for us, Brunch won out because it had much less configuration and much better documentation. So Webpack, I think, has been a great project. Even at the time, it had some nice features like static analysis, but the configuration was pretty esoteric at the time, and the documentation wasn't there. And for us, the biggest thing with the asset builder is, one, it should be swappable. So it's always, you could always use Webpack in just a couple changes to your project. But for us, we're tailoring it towards Elixir newcomers. So not everyone coming into Elixir is going to be building a React single-page application and be a Node.js expert. So we can't rely on people knowing how to configure these things, how to properly run them. Some people just want to run JavaScript somewhere or put the CSS somewhere, and it gets loaded into the application. So for us, with Webpack 4 that was just released, we kind of got everything that we wanted. So the Webpack team has done a great job now that they have minimal configuration. So our configuration with Phoenix 1.4 is less configuration than Brunch had. And there's vastly improved documentation with Webpack 4. And like I said, now we gain these great dead code elimination features. So your app.js bundle size is going to be much smaller now that we're using Webpack than what you were seeing with Brunch. So there's some nice improvements there. And it's the same dev story that we had with Brunch and Phoenix. Like, there's still going to be an assets JS folder, an assets CSS folder. Drop your JS and CSS in there, and it's going to get bundled. So if you don't particularly care which asset builder we're using, the story doesn't change at all for you. So that's coming in Phoenix 1.4. And as far as JavaScript changes, so some good news and bad news. I'll do the bad news first. Bad news, like if you're using presence with Phoenix.js, your app has a race condition. The good news is it can be fixed with a much nicer API, but the bad news is that there is a bug in your current code. This was the old API. So we went with this like pure functional API. Like we had present sync state, present sync diff that took a data structure and returned a data structure. It was pure. It was functional programmed. It was nice. And there was a couple of magic events that you had to know, like present state and present diff, but it wasn't a bad API. But it turns out the race condition, it happens when there's different channel lifecycle changes with the connection. So we had to create a stateful API around presence to resolve this race condition. So the new API is much nicer, much simpler, and it fixes your code. So this is on master now. This will come out with 1.4. The old API still exists internally, so you could drop the new Phoenix.js in your project and not change your app code, and it would still work. So we didn't break that API. We just built on top of it to handle the lifecycle events. And we also condensed, now there's just like you can say let presence equal new presence. So create a presence instance, pass your channel in. It's going to handle those seemingly magical presence state, presence diff events, and then condense that to a single on-sync function. So anytime your presence state changes on the server and you get synced with the server state, just render your updated presence list, and then presence on join and presence on leave to detect when users come and go. So much nicer API, but there is a race condition. You're not necessarily experiencing it. It's only under certain connection drops and reconnects, but it is there, and it has to be fixed with a new API. So that's it for Phoenix 1.4. Like I said, the only remaining changes are really on making the channel transports more extensible. Like if you wanted to change the way our WebSocket transport works today, you'd have to do like a copy-paste of a bunch of code. So that's ongoing work. There should be relatively minor user land changes maybe to your user socket, some deprecations, but you're not going to have to rewrite your channels or anything. So it should be, most of the user-facing features are baked at this point. So I want to focus the rest of the talk on kind of this stateless world that we have with web application development that we're used to, and the stateful world that Elixir really and Erlang and OTP provide us. And I think a lot of contention between these two worlds and a lot of uncertainty. So I want to kind of give people a mental model on how to think about stateless applications and stateful applications and where Phoenix and the database fit into the mix. Because if you're like me, you came to Elixir and you realized like we have this amazing platform that I can, let's say, develop 3 applications in an umbrella app, I'm building an e-commerce store, and I can say, well, I want to start commerce application to be the main business logic of my platform, and then I can make my web bits in Phoenix into another app, and I can make a warehouse application running, doing like inventory counts. Like if you ever work professionally with inventory systems of physical warehouses, they're likely terrible. Like a lot of them will, like the process is like someone physically uploads a CSV, FTPs it to a server, and like you have to go fetch that every 24 hours and like update your counts. So there's a lot of things there that are a lot of data ingestion. So you probably want to deploy that separately and manage that as a separate application. So the amazing thing is we can like run this in one VM on our laptops, and if we have a gen server call to our warehouse, it's going to be like a PID or a registered name. Like that's just going to work. And then ideally, in a perfect world, we deploy this to 6 servers and we don't make any code changes in a perfect world. And so this is really exciting to people. And so they think like we have now this VM that lets us make distributed messages that are seemingly location transparent, and we can have these processes hold state somewhere. I can just tell the warehouse, decrement some stock, and run it on a cluster of machines just like I would on my one server. So this is really exciting. I think people rightfully get excited about this. So I think what happens though is like we get really carried away with this, and we think like, you know what? Like every step of the way, our thought process kind of pushes us away from the database, or thinking we don't need a database. And I think I'm going to kind of dial back people's excitement and try to give them at least a decision process to make. Because I think you get excited, you come in, and you hear and you kind of know that like a lot of languages and frameworks push us to rely on the database too much. So like, you know, we have a web framework, and we build our application around the web, so we're used to just shoving everything in the database. And if we need to manage any seemingly ephemeral state, we'll still put it in the database, pull it back out. And we know that Elixir is built for stateful systems, and it starts feeling really good to write like gen servers. And our processes are distributed by default, so it's like, well, if I can start servers somewhere and pull state from seemingly anywhere on the cluster, like maybe I don't need a database in my program. Is a good default case to arrive at, but I think people arrive at this and then just throw the need for a database out the window because Elixir is seemingly great at stateful applications. So now I'm going to dial back the excitement a little bit by going through a tic-tac-toe champion game where I am the winner. Better than Jose and Eric, at least. So I want to give people some idea of like how to internalize, like should I use the database, especially when they're building a Phoenix application or Phoenix project. It's like where does the database come into play, and where should I use this secret sauce OTP that I keep hearing about, and why does Phoenix include a database at all? So I want to give people a mental model to think about these things because it's actually pretty easy to reason about. So let's walk through a tic-tac-toe game. And in this case, like we want a database because when I restart the cluster, I want to see that I'm still the winner historically. So I don't want to lose that information. So we know up front we need some kind of persistent state, right? And that's going to be our leaderboard. But internally, I don't have to write a program that just shoves every player move into the database, right? I can write a gen server that is going to hold some state, and as users make moves, right, I can just keep that in a process state, update the board. And the nice thing is I can bring the database in when I need to. So James Edward Gray and Nathan Long gave a great talk last year where they built a game where they said, rightfully so, like as they were building the game, they wrote gen servers, they put it in a supervision tree, and when they wanted to then implement the requirement of persisting the game history, that's when they thought about the database for the first time. Like the database did not drive their architecture or design decisions up to that point. And to me, that's a really important mindset to internalize. Like, we shouldn't let the database drive the designer of application. Like, we shouldn't just shove everything in the database. Like in this case, we only care about the database when someone wins. So we can just say, okay, I'm writing my gen server, and okay, if someone won, what do I do? Well, I write a function to persist the game results. Then I reach for my Ecto repo, I insert some data, and I persist the results. And the great thing is, like, I don't even have to touch the database necessarily. Like, coming from Ruby, I had a lot of code historically that, like, data that could get into states where it was incomplete but abandoned. Like if users came to the website, started some process, like started some workflow, and ended up not signing up or completing. I used to have to write background tasks that would, like cron, that would go through and like say, hey, if this database record was in some incomplete state and last updated less than 12 or greater than 12 hours ago, prune those results. But with Elixir, it's like, no, we write stateful systems, and if someone abandons the game on their web browser, we just terminate the process, right? We don't even have to touch the database. So like this feels really good. So right, we start a process, and we have a bunch of ephemeral state, and the ephemeral state is like the user moves, right? We don't care about the order that they happened in. So like messages are going to our process, we're updating our states, we're not persisting these results. Dozens of moves or one moves later for tic-tac-toe. We have a win, we persist, and that's the first time we think about the database, right? We like, okay, we need to persist it now, and we have like a one-liner call, maybe to an ecto repo, maybe to just some other cold storage, right? And like this feels really good. So I think people rightfully, like they're like, oh my gosh, like I didn't have to think about the database at all until this one point. And then I dropped echo in, and it feels so good, and you should internalize like this is the way to go. And I think the problem though is like this feels so good that then they apply this to everything they're building, and this is where you get into trouble. Because you then say, okay, I implemented this tic-tac-toe game, but now I'm going to go back and I'm working on a CMS for a client, and I run a Phoenix generator, like mix Phoenix gen CMS. I'm going to generate some post content for a page, and you're like, okay, what's this thing that Phoenix generated for me? And you open up CMS and you see like, oh my gosh, like this just threw ecto in right away. Like the whole app is revolving around the database. Like what is Phoenix doing? Why is it pushing people to insert stuff in the database directly? Why isn't it starting a process? So I think people take this previous step, what felt so good about writing a gen server, using what they've heard is this awesome sauce OTP, not thinking about that database till the end, and then Phoenix generates some code for them that just inserts the database. And there's these two worlds, and you're like, well, why isn't Phoenix starting a process, right? Why aren't we using OTP? You know, hand wavy, but like internally, repo is using a process pool and doing a bunch of stuff for you. But the biggest takeaway for me and what I want you to think about is like these two applications here we see, like these are different things, and they require different solutions. So the outline.com is actually running Phoenix. It's a news website. And they're using Postgres and inserting things into the database, right? Like if I'm viewing a content website, like this is data that's going to live for years, right? That's something that's going to be in a database somewhere for us. But what we see on the other side looks like a video. It's just a screenshot of a tweet. But you should check it out if I can find the link to the tweet. But someone on a hackathon made a Phoenix channels-based game where all the 4 people standing around with their phones have a web page with a game controller, and like all the touch moves, anytime they move their joystick, the dots on the screen are going to update. And that's running in some process on the Phoenix and Elixir side. And like they're not storing that data in the database, right? Like they're not doing on-touch move every 15 milliseconds that the browser sends. They're not going to update all those moves to the database, right? They're going to persist some game high scores, but they're building a very different thing than a content-based website, right? So I think people need, when they're having these different arguments on is the database necessary for my problem or not, you need to understand what you're building. And some things that we build and what we often build for day-to-day business needs are putting things in the database, using transactions, doing things that the database is great at. And some things are building these stateful systems, and they are very different things. And Phoenix will gladly do both, right? We have a stateless web tier, and then we have a channel-based layer for your stateful systems. But they're very different problems. And when we have these different sides of is the database necessary, we have to understand what we're building. Because the database is our friend, it turns out. Like if you're like me, coming from a web background, there's a whole class of problems and questions that you don't have to ever think about. Like you just can free your mind about like, okay, what about if something happens like halfway through registering a user? What do I do? What about having consistent data? How do I guarantee uniqueness? How do I do backups? What about replication? Like there's a lot of things that you just never think about because the database has done it for you always. So I would caution people to think like we have this amazing stateful systems that we can build in Elixir, but the moment we want to say, hey, these are better than what we can get by putting things in the database, we need to understand the decisions that we now have to make. So I was trying to come up with a metaphor for this, and in my head I was like, you know what, it's kind of like a choose your own adventure book. And if you're not familiar, these are like, at the end of the chapter, you get to choose like, if you're like in a forest, it'd be like, continue down the path, or like, walk into the stream, and like based on your choice, the story changes and the ending of the story changes. So I was trying to look for covers, and I was just going to make this point, and then like the first cover I found ended up perfectly describing like the different guarantees in a distributed system and like the decisions that you now have to make yourself on the side cover. So this is great. It's like you are the star of each story. So like if you want to say, you know what, we don't need a database, and I want to run stateful systems, it's now like now you as the developer have to make certain decisions that you can't avoid. So like it tells us what happens will depend on the decisions that you make. You will decide how the story ends. So like if we want to start running these stateful systems, like we as a developer, like it even underlines you, like we have to make decisions. And the decisions we make are going to decide like what happens when our application fails, what happens if we spawn two processes that are supposed to be representing the same thing. So we have to make decisions on the guarantees we want. And it even tells us like you'll travel to foreign lands and go back and forth in time. So like if you're trying to have certain guarantees in a distributed system, you can't just like put a timestamp on an event and then compare the time, right? Like there's clock drift on a server, the speed of light is going to come into play. Like your whole, the whole world that you used to think of like, oh, I'll just put it in a database, gets suddenly much more complicated. And then I was looking at other covers, and I found even better cover. Like there are parody covers for Choose Your Own Adventure books. So the one I found was like, you're the star of each story. Choose from 20 tragic endings. And then don't bother, you die in most of the endings anyway. So like I said, I don't want to tell people don't build stateful systems in Elixir. Like this is what the platform was built for. But just understand that you have to now make a lot more decisions that you used to have, that used to be taken care of for you in the database. And then this isn't like, this is a joke, but like we have people that, I'm going to pick on MongoDB a little bit. Like there are crypto companies have built their applications on top of like Mongo because, databases and money, I don't know. But what would happen is they chose MongoDB, and then they forgot that like, ACID transactions were a thing that was good, that most databases provide for you, and they weren't thinking about the guarantees they wanted, and it allowed people to like double spend in the application, and they lost millions of dollars. So like literally like the decisions you make as soon as you want to step outside and do a distributed stateful system like could end badly if you don't know the questions that you need to ask. So I want to walk people through how this works with another simple example, but slightly more sophisticated than our tic-tac-toe game. So I wrote a blog post actually around building a rate limiter, and I left off the spoiler alert that it was incomplete, and we'll walk through why that is. But let's say that the requirement comes in from our client, like, hey, I need a rate limit request to my software as a service, right? Like if users are paying for a free tier or a paid tier, I want to say they can only get X requests per minute. And for me, as like it's an okay default to say like, let's say like, do we need the database or not? Like that's a good default to start at. And for me, it's like, well, we have state here, so we need to have store state somewhere, and it's okay to say maybe we don't need the database as a starting point. And if we think about a rate limiter, like this is going to be something that every request that hits the app needs to call the database, potentially over the network, and check a value and then update a value. So that's potentially extremely expensive as far as like, if we get 10,000 requests per second, we're going to be slamming a database table over the network 10,000 times a second. Like that's going to potentially really hurt our performance. So I think it's okay to say, you know what, if we can avoid the database in this case, use this amazing stateful system that we have in Elixir, let's do it. So we can implement this with a gen server, and we can cheat by, one problem people have in Elixir is they start a gen server and then they send all traffic to one process, and they have a big bottleneck. But in this case, our public API of rate limiter log, we can actually use ets, which is like an in-memory store in Elixir, or sorry, in Erlang, which is amazing. The APIs are a little bit esoteric, and the errors are always argument error, but it's amazing technology underneath. You just, like me, like this update counter example, like that was probably my 30th attempt in IEX that didn't throw an argument error, and then I was like, all right, I got it. It works. But what that does for us is it's an atomic update. So ets has a counter that will guarantee an atomic update to that value, so we can have concurrent writes for a same user and guarantee that we're not going to erase those two writes. And we don't have to call a server for that, but we can start a gen server then that owns that table that just every 60 seconds is going to delete all the objects. So this way, we have our requests per minute that each user is making. and we're doing concurrent writes to an ETS table and then sweeping every minute. So this is like super fast. This is going to meet the needs that we have, and it's also going to avoid a database. So it's probably going to be like 100 times faster than calling the database. So this is awesome, and this feels really good. And this is where I ended my blog post. But now let's continue, and let's deploy this. So we deploy it, or we run it on our laptop. We call rate limiter log. It just works. We're using ETS, which is awesome, and it feels really good, right? We're like, yes, no database. Elixir's so good. And then we go to deploy it to production, and we're like, oh, it completely fails. Except it doesn't, except it works exactly as we wrote it. And this is where it gets tricky, right? Like as soon as we deploy this on a cluster of machines, our rate limiter is going to be running on each machine, and ETS is in memory on that one machine, right? So now we have a ETS table per load balance web front end keeping counts of the requests that the user just happened to load balance to. So we'll have different rate limited counts per node based on what our load balancer happened to do with that user request, which is not good, right? Because now people are actually getting more requests per minute, much more potentially depending on our cluster size, because we weren't thinking about the guarantees we wanted in the system. So you're like, okay, well, Elixir and Erlang are awesome, so I can fix this. So we'll just say, well, we need to replicate data now, right? We're not, we didn't use a database. There was no single source of truth. There was no replication happening. So we'll just throw PG2 in here, right? We can use a distributed process group. Every 10 seconds, we'll just send everyone all of our data, right? And we can do that with a send interval. And all we have to do is just say, dump our entire ETS table to a list and send it, replicate it out to everyone. And this is overly simplified, right? But this actually would work. So I'm not saying this is a robust solution, but this is probably what, like Mongo's replication is probably very similar to this here. But I was getting ready to say, like, this would be super slow because we're exporting all of our entries. And then I benchmarked it, and for like 50,000 ETS entries, so if you had 50,000 active users per minute, when you receive that list here, and like when you get this replicate function, we have to go through 50,000 elements in the limits list, and then call update counter 50,000 times. So I was getting ready to say, like, you would never want to do this, but then for 50,000 ETS elements, this took 0.02 seconds. And it's one of those things, like, ETS is like, I don't believe it half the time. So this would actually be a viable solution for like 50,000 active users per minute, which is insane. If you ignore, like, there are some timing issues with this that we're going to ignore, but the key thing I want you to realize is, like, we can do the replication ourselves. We've solved our distributed state problem in that when we go to deploy this, we're going to be load balancing now on a somewhat up-to-date list of requests per minute. But we have to make a trade-off here, right? Because since we're replicating our data every 10 seconds, we can't do it every time someone visits the app. We can't replicate 50,000 entries every request we get. So we have to make it delayed, chunk those out every 10 seconds. But is this okay? We have to make this determination. Like, is the loss of consistency here? So like if someone may get 200 extra requests that minute, potentially. And for a lot of business cases, that's totally fine, right? If we have a geolocation API, if someone gets 200 extra requests on like points of interest, that's not going to cost us money. But if your business requirement is like, hey, we print stickers, we have an API that you can literally print a sticker and ship it. Like if someone gets 200 extra requests that minute, that costs us tangible dollars. That's a big deal. And then we say, well, our guarantees are different there. We need consistency, so you're going to need some database of some kind, right, for that case. So there are certain decisions you have to make around handling states, and you may have a process, but you may be centralizing that state into some cold storage somewhere, likely using something like Postgres for certain business cases. But you have to make that decision. So I do think, like, for rate limiting, I do think a more robust solution, much like this, is actually perfect, because like we don't really care in most cases that users got a couple extra requests per minute, and this is much faster than talking to a database. And there's also, we could put amnesia in here and have something handle our replication for us. But ultimately, I do think starting from this problem, starting with, hey, let's not just shove requests in a database, is the right solution, but we have to think about the guarantees we want once we go down that path. And then there's a whole other class of problems that once you say, okay, I've tackled the distributed state problem. Let's say it's solved. Boom. I know the guarantees I want. Then you have to start answering other questions that you didn't have to answer before. Like, let's say we're writing a game and people can start new games, like Xbox Live. People join a new match. where do we spawn that game server at? So like if you have a web front end that like say our tic-tac-toe is wildly popular, and our tic-tac-toe is a board of like 10,000 blocks instead of a few. We want to not start that on our web front end node. We likely want to have some game server or series of game servers to start that game server on. And you can think like a lot of games, especially like massive multiplayer online games, you often want to place those processes close to one another. So like if you could put all the users in the same world on one server, you would vastly improve latency because you can just keep the message sending on one server. So there's this problem of process placement that is a very complex topic with different answers, but I'd love in the community to have some answers to this. But these are ultimately questions you're going to have to answer for yourself. And when you can't answer, like, where do I start this process? And it may be on the same single box that you're running Phoenix on. You still have to be able to find it later. So if we start a game somewhere and we don't have the PID, but we have the session ID or the game ID or the name of the game, how do we find it later given some name? And this is where like process registries come in. And if you're using Elixir's registry, it's great for local node registries, but if you want global name registration, you either have to reach for Erlang Global, which may be fine, but it may not scale to your needs, so you have to start answering other questions. And for me, it's like we need better tools for this. So I'm not saying that like you can't build these amazing systems today. I think if you're an expert, you've been in the community for a while, there are solutions out there to all of the problems I've talked about today, but they're ones that you kind of have to know which questions to ask and then know which libraries to look for. And for me, like I said, I think we need better tooling for these things. And I think to really say that like, don't use the database by default, we have to start answering like, instead use this, or instead here are the things you need to ask yourself. And based on your answer, use these 3 tools. Because for me, I'd love to have people just say, write a game, spawn a process somewhere, and if they can answer the guarantees they want, then it should be obvious what their next steps are. And having said all that, though, like the moment you want to say, like, okay, a user visits my application, they click sign up on the web, and then we want to register a user in some accounts context, like, we're going to throw Postgres in the application, right? Like, so even if Elixir has a solution to all these problems I've mentioned, like, you're going to ultimately have some complemented architecture, right, where you're going to have some database. And likely today, SQL remains an amazing option. So even if, let's say, someone implements a database that gives us all the guarantees that Postgres gives us in Elixir, like, that's still going to be a database, right? So, like, ultimately, even if we have a pure Elixir stack that gives us ACID transactions, replication, like, that thing's still going to be a database, and it's still going to be part of our architecture that we're going to call on the network somewhere. So the same rules apply. So we're going to have a complemented architecture no matter how far we get into OTP and stateful systems. I think we can build amazing things, but it's going to be complemented with the cases where we want the guarantees of database. And I want people to really internalize that. But we can do better. So I think that's what Phoenix and Elixir have been doing right from the beginning. So I wrote Phoenix as this real-time web application framework. I think originally our tagline was like what I call it, highly connected web framework. Like, I wanted it to be all about real-time connections. So to get real-time connections going, I needed a pub/sub layer, and then I realized, oh hey, Elixir gives us like this distributed process model out of the box. So Phoenix pub/sub is this distributed pub/sub layer, and it was like incredibly easy to write. And most existing platforms outside of Elixir and Erlang, you don't get distributed pub/sub, or someone says like, okay, throw Redis in there, or throw a message queue if you want to get those messages across the cluster. So for us, we took the primitives of the platform, and we were able to get distributed pub/sub in like remarkably small amount of code. And then we continued with like Phoenix Tracker and Phoenix Presence, which gave us like a distributed process group, and we built on the existing primitives of the platform. And I think like Elixir has done an amazing job with that. Like even their task module, like if you imagine Erlang had these amazing primitives, like you can start these processes, these cheap bits of concurrency, but if you wanted to say like, hey, can I just use all the CPU resources on my machine efficiently? Like that was actually really hard to do. Like before we had like task async stream. If you just tried to replicate that in Erlang, it was actually not obvious how to do that. And Elixir just gives us that seemingly for free, building on top of these primitives. So I think if we continue as a community to say, like, we have amazing tooling today, but how can we make it better? How can we use the primitives we have to make distributed applications just as trivial as like what task async stream did to concurrency, then I think we're truly going to eat the world. So that's all I have. Thanks a lot.